Now we're looking at example 2 from our 2.2 set of notes. We're asked to find the derivative of this particular function, specifically at this particular x value 1. Going ahead and using our definition of the derivative, we have the derivative, or the slope of that tangent line at 1, comes out to be the limit as h goes towards 0. And pretty much anywhere that there is this x, we're going to go ahead and throw in our target point 1 plus some distance that we are away from that target x value of 1, quantity squared minus 1. Again, this represents the y value of that other point for our function that's close to our target point. Now we're going to have to go ahead and subtract that by our target point's y value. So we have f of 1, or 2 times 1 quantity squared minus 1. Again, just basically throwing 1 into that function and seeing what that y value comes out. And again, this is all over h. Going ahead and simplifying this, we end up then with the limit as h goes to 0. Just for the sake that we're all on the same page, I'm going to go ahead and rewrite this as 2 times 1 plus h times 1 plus h minus 1 minus, over here we end up with 1 squared is 1 times 2 is 2. 2 minus 1 comes out to be 1. So again, 1 squared is 1 times 2 is 2 minus 1 gives us 1. And this is all over h. Now we can go ahead and FOIL this. And when we FOIL that, we end up then with, we still have the limit as h goes to 0 of 2 times 1 plus 2h plus h squared, when you FOIL that out, minus 1 minus 1 all over h. Going ahead next and distributing in this 2 into all of these items, we end up with the limit as h goes to 0 of 2 times 1 is 2 plus 4h plus 2h squared minus 1 minus 1 all over h. Simplifying this even further, we have the limit as h goes to 0 still. 2 minus 1 gives us 1 plus 4h plus 2h squared minus 1 all over h. And now we can go ahead and combine the tops. So, or I'm sorry, now we can go ahead and combine these negative, or this 1 and this negative 1. They just end up canceling out with one another, leaving us then with the limit as h goes to 0 of 4h plus 2h squared all over h. And now we can go ahead and factor out an h on top. Because right now, if you were to try direct evaluation, you would still get that 0 over 0 in determinate form. So we have to maybe factor out an h. And when we do that, we have 4 plus 2h all over h. And now you can see that these h's end up canceling out with one another, leaving us then with the limit as h goes to 0 of 4 plus 2h. Going ahead now and using our direct evaluation, we end up then with 4 plus 2 times 0, which then just gives us the slope. So the slope of the tangent line, specifically at this x value 1. And again, pretty much in terms of like function notation, what that would look like is we have the slope, or the derivative, of our function at this particular point comes out to be 4. So again, that is example 2 from our 2.2 set of notes.